Welcome to Episode 9, Pinpoint PCI Scope and Network Segmentation with Certainty. The promise today is a reliable scoping method that avoids both under and over inclusion, so boundaries feel precise rather than political. We will build a calm way to read environments the same way every time. Start with where payment data actually lives, follow how it moves, trace who can influence those paths, and finish by marking technical controls that prove separation is real over time. The Payment Card Industry Data Security Standard, PCI DSS, rewards clarity about what is in scope and why, because that clarity turns into clean sampling, right-sized evidence, and faster assessments. When teams feel unsure, they either pull too much into scope and drown in noise, or push too little and leave gaps that surface at the worst moment. Your method will strike the middle, tight enough to be defensible, broad enough to be safe. By the end, you will be able to narrate scope in one steady minute data, path, trust, control, and point to the artifacts that make those words more than a speech. That narration becomes the backbone of segmentation decisions that hold up under questioning and over time. Start with shared language, because definitions shape the map before diagrams ever do. The cardholder data environment, or CDE, is the set of people, processes, and systems that store, process, or transmit cardholder data or sensitive authentication data, along with the system components that are directly connected to those systems. That second clause matters, because directly connected pulls devices and services into scope that can reach the CDE without crossing a control that meaningfully reduces risk. During assessments, scoping tests sound plain but cut deep. Identify where primary account number appears in clear text. Identify where sensitive authentication data could appear even transiently. Trace network paths that could carry that data, and enumerate management channels that can change configurations on in-scope systems. Then try to break your own map by asking whether any host, platform service, or identity system could alter or observe the CDE without going through a control you test. The test is as much about verbs as nouns: store, process, transmit, manage, monitor, because verbs tell you who can move risk even if they never see a packet. Speak those verbs whenever you classify, and scope sharpens. With definitions set, pull the first circle with confidence. Systems that store, process, or transmit cardholder data join scope immediately, without debate or delay. Storage includes databases, file systems, object stores, queues, caches, and backups where primary account number might land in whole or in part. Processing includes application tiers, batch jobs, tokenization services, and fraud engines that operate on clear text. Transmission includes load balancers, API gateways, reverse proxies, and network gear that forward or terminate sessions carrying card data. The evidence that anchors these calls is concrete: data flow diagrams that show fields and formats, configuration exports from systems that touch payloads, sample messages that prove masking and truncation actually happen, and inventories that name the components by role, owner, and location. In practice, this first circle is smaller when tokenization or point-to-point encryption appears early, and larger when integrated web collection or complex settlement flows exist. Either way, do not let arguments about business convenience cloud the rule. Where clear text lives or moves, scope follows, and the burden to prove otherwise rests on design, not optimism. Decisions are cleaner when you can point to a line of text rather than a hunch. The second circle captures systems that could impact the security of the CDE even if they never touch card data directly, and this is where over- and under-scoping often break programs. Think about jump servers used to administer in-scope hosts, logging and monitoring platforms that collect and analyze events from the CDE, directory services that grant accounts the power to change configurations, and time sources that keep logs correlated. Vulnerability scanners, patching platforms, and deployment pipelines also shape the CDE's reality because they can deliver fixes or inject faults at speed. Typical evidence here includes access models that show which identities can reach which devices, firewall or security group rules that either block or permit privileged paths, platform inventories that place shared services on their own segments, and workflow tickets that document who approved what change and when. The test you apply is whether a compromise of the system would reasonably let an attacker alter the CDE's security posture. If yes, treat it as connected for scope unless a segmentation control reduces the risk to a level that is both argued and proven. This circle is where precision pays dividends because clear boundaries save months of busy work later. A boundary is only as good as the network that supports it, so contrast flat designs with segmented ones and notice how assessment work changes accordingly. In a flat network, broadcast domains and permissive routing make any node a potential stepping stone to any other. A single compromised desktop can pivot to a payment application with fewer alarms and less friction. In a segmented design, enforcement points, from Layer 3 firewalls to tightly scoped access control lists, thin the number of possible paths, and routes between zones exist only for defined purposes under logged, reviewed rules. For assessments, flatness multiplies sample sizes and investigative effort, because a wider population of systems can influence or observe the CDE. Segmentation shrinks the population you test by putting a wall between can reach and cannot reach, which means fewer devices, fewer people, and fewer changes are in play when you gather evidence. The trade is clear. Invest in segmentation discipline and buy down assessment friction. Skip it and pay in sustained testing and a higher likelihood of unwelcome surprises. Neither path absolves you from rigor, but one clears the way for rigor to be practical all year. Segmentation works when controls are specific and layered, not when they are slogans. So name the tools and the proof that make separations real. Firewalls enforce stateful rules that bind source, destination, port, and application where appropriate. Access control lists on routers and switches provide deterministic blocks and allows at choke points. Jump hosts concentrate administrative access through hardened bastions with multi-factor authentication and session recording. Proxies and brokers mediate outbound requests so that application tiers cannot wander the internet at will. Strict routing rules remove default paths and force traffic through inspection points that you can monitor and sample. The shape you seek is narrow flows that match a real business purpose, with deny by default everywhere else. Evidence must live at two layers: configurations that show the intent and logs that show the controls working under normal load and during change. When you can hold a printed rule and a week of matching flow records in your hand, segmentation stops being a whiteboard promise and becomes a testable fact. Assessors respond to facts with smaller samples and shorter interviews because the posture speaks for itself. Validation separates hopeful drawings from durable boundaries, so run a straightforward regimen and keep the results. Sampling begins with route and reach tests across zone pairs where traffic should never succeed. Packet traces or flow logs then prove that allowed paths carry only the intended protocols and destinations. Access reviews confirm that only named identities can administer the devices that enforce the boundary, and that approvals and expirations exist for elevated rights. Periodically, perform a change-aware validation after you modify rules or add a new application path, and attach the validation outputs to the change record so the artifact trail remains complete. On the human side, ask engineers to narrate the path an admin would take to reach a CDE host. Then verify each hop is gated by multi-factor authentication and recorded. If the story includes "we sometimes," the control is weaker than you think. A small checklist keeps this sane. Test cannot, test can, test who, test when. Cannot is your deny baseline. Can is the explicit permit. Who and when bind the privilege to people and time. Run it quarterly, run it after changes, and sleep better. Wireless, remote access, and shared services like DNS and NTP deserve special care because they often slip past tidy diagrams and land in scope by surprise. Wireless segments that touch or traverse the same switching fabric as the CDE must be treated with zero-trust assumptions, with strong authentication, isolated VLANs, and firewall rules that refuse lateral movement except for documented management flows. Remote access into the CDE or into its administration jump hosts requires multi-factor authentication, least privilege role assignment, and session recording wherever feasible, and split tunneling must be engineered away so that remote devices are not silent bridges. Shared services such as DNS, NTP, directory, and certificate authorities can become scope multipliers if they are co-located with casual access or if their management channels are not fenced. The safer pattern is to host them in service networks with hardened paths into the CDE and to log their use as if every query mattered. Treat shared as a risk word. Shared can remain shared only when the sharing is documented, mediated, and visible. Virtualization and cloud constructs blur boundaries because proximity looks like trust And convenience looks like control. So document what isolation truly means in these platforms. In virtualized data centers, hypervisors, management networks, and storage fabrics can influence guests without ever appearing in application diagrams. Place management planes on their own protected networks with jump host access and keep guest-to-guest communication explicit rather than opportunistic. In public cloud, use accounts, subscriptions, or projects to separate CDE from non-CDE, and then apply virtual network segmentation, security groups, route tables, and private endpoints to make traffic shape follow your narrative. Services such as managed databases, message queues, or serverless components must be treated as in scope when they carry or transform cardholder data. The managed label does not change the verbs store, process, or transmit. Evidence here is rich but knowable: templates, policies, and code that define the infrastructure, configuration snapshots of rules and routes, identity policies that prove least privilege on consoles and APIs, and flow logs that show traffic stayed inside your declared lanes. Write your cloud scoping like you expect an argument, then win it with artifacts. Shrink scope through design, not debate, and do it by removing data flows and tightening access paths in a realistic scenario. Imagine a commerce stack that collects payment details on the merchant page, stores tokens and full primary account number in an order database for flexibility, and allows support staff to connect directly to application servers from corporate laptops. The safer redesign moves entry into a provider-hosted iframe or redirects to the provider, tokenizes at capture so downstream systems never see full PAN, and deletes legacy columns that once held clear text. Administrative access collapses into a hardened jump host with multi-factor authentication and session recording, reachable only from a privileged access workstation tier that cannot browse the internet. Logging points to a centralized platform that is segmented yet permitted to receive the CDE's events, and the order database keeps only tokens plus masked references. When you narrate that change, scope shrinks because clear text disappears from places it once lingered, and because the number of trusted paths collapses to a handful you can actually verify. That is not a policy victory, it is an architectural one. Even tight designs fail when transitive trust, shared management, and overlooked admin tools reopen paths you thought were closed, so hunt those pitfalls on purpose. Transitive trust appears when an administrator can jump from a non-CDE system into a CDE segment through an innocent maintenance path, or when federation grants an overbroad role the right to change both sides of a boundary. Shared management networks that let a single out-of-band interface reach many devices across trust zones can invalidate a year's worth of careful rule writing if they lack their own access controls. Overlooked tools, backup agents, orchestration daemons, monitoring connectors often run with system-level rights and carry credentials into places change tickets never mention. The cure is catalog and control. Enumerate all management channels, restrict them to dedicated networks with their own jump hosts, bind them to least privilege identities with short-lived elevation, and record their use. Then test the negative case every quarter. Prove that a normal workstation on a general segment cannot reach a management interface for a CDE host, and prove that a general admin cannot assume a CDE role without a fresh approval and factor. Scope does not stay correct by memory. It stays correct by ritual, so keep a quick checklist for annual confirmation and change-driven reviews. Start with a spoken inventory of where primary account number appears, including transient paths. Compare that to data flow diagrams and update the diagrams when reality wins the argument. Review segmentation policies and rules for drift and attach a small testing log that shows you ran cannot and can checks for critical pairs. Reaffirm shared services placement and their management paths, and collect provider attestations of compliance, AOCs, and service descriptions, mapping them to your shared responsibility notes. Walk a sample of change records that touched boundaries, firewall rules, route updates, identity policy changes, and confirm post-change validation happened with timestamps and names. Finally, pick one environment with history and ask whether any forgotten batch, export, or tool now carries weight it did not when the last assessment closed. The list is short on purpose, so it gets done. Done beats grand in this domain every time. When the room is noisy, a memory anchor helps you recite scope without reaching for documents, so use 4 short words in one line: data, path, trust, control. Data asks where primary account number or sensitive authentication data exist in clear text, even for a moment. Path asks where those bytes can travel, on purpose or by accident, including management channels that can push configurations into the CDE. Trust asks who can influence those data and paths through identity, platform, or shared service roles, even if they never see a payload. Control asks what prevents movement where it should not happen and what proves allowed movement stays inside declared lanes. Say the line slowly: data, path, trust, control, and you will feel your questions change from opinion to verification. The best part is that any teammate can learn this anchor in an hour, and when everyone says the same words, your scoping arguments turn into scoping evidence with less friction and less ego. Bring the method to life by narrating a scoping walkthrough for an environment you actually know, because lived detail beats hypothetical polish. Start at the edge where payment data enters, store device, web iframe, mobile SDK, or phone desk, and say who owns that step and which artifact proves safe capture. Trace the path to the gateway and acquirer, naming the encryption in transit and the logs that show it works. Call out any middleware that touches messages and show whether it ever stores clear text. Step into the administrative lane and name the jump host, the factor, the approval, and the session recording that make privilege observable. List the shared services the CDE depends on, DNS, NTP, directory, logging, and say where they live, how they reach in, and what keeps them from spilling over. Then point to backups and replicas, and close with disposal and retention. Your voice is the audit's first control here. When it is crisp, the rest of the controls find their places faster. As your confidence grows, fold cloud and hybrid realities into the same cadence so your scoping does not lag behind your architecture. Treat account or subscription boundaries as walls only when the identity and network policies prove they are walls. Use private connectivity and route control to keep payment flows off the public internet, and attach flow logs everywhere so you can prove intentions with packets. Build landing zones that pre-segment environments by purpose and sensitivity, and keep CDE resources out of shared automation unless the automation's management plane meets the same bar you demand of a jump host. Use infrastructure as code to make your boundaries readable and replayable, then review that code like you would a firewall change. When teams show you a pretty architecture slide, ask to see the template and the last approval that moved it to production. If those artifacts are near at hand, scope is likely as real as the diagram. If they are not, the diagram may be fiction dressed as a plan. Finally, tie scoping back to the human moves that keep it honest in the messy middle of a project. Teach developers that no primary account number in test is not a motto but a gate, enforced by data generation and checked by scanners that fail builds when forbidden patterns appear. Coach support to refuse sensitive authentication data, and configure ticket systems to block or strip it so policy cannot be defeated by habit. Give network engineers a small, shared library of deny-by-default examples and a routine for adding permits that always includes a test case and a log review. Ask platform and security teams to maintain a one-page shared services placement note with ownership, paths, and last review date. It is the paper that prevents endless meetings. When people can show their part of the boundary without calling a committee, assessments move at the speed of the work rather than the speed of the calendar. We will close by returning to the promise of certainty built from simple moves. Scope stops being a tug-of-war when everyone can say, in the same calm voice, where data lives, where it can travel, who can influence those paths, and which controls keep reality inside the lanes you chose. Segmentation turns from a diagram into a lived boundary when firewalls, access control lists, jump hosts, proxies, and strict routing rules leave footprints you can sample today and again after change tomorrow. Wireless and remote access no longer feel like exceptions. They become named, fenced roads with logs at every toll. Cloud constructs stop feeling mystical. They become policy, template, and flow record. Your assignment is to record a brief, narrated scoping walkthrough for one environment you know, store, web, or mobile, and keep the four-word anchor in the recording so the rhythm sticks. Precision earns trust, and trust makes assessments faster. Most important, a precise scope puts protection where it matters and nowhere else, which is the real point of the work. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.